Alright guys, welcome to Learnlyte. In this video we're going to talk about inheritance and polymorphism as it relates to object-oriented programming in Python. So let's begin. So what is inheritance? Inheritance is a feature of object-oriented programming that allows the programmer to create a new class which is simply a modified version of another class. The new class that is created is called a subclass or a child class, and the class from which the child class was created or modified from is called the parent class. When we create a child class, the child class inherits all the parent class attributes and the parent class methods, hence the term inheritance. This is very powerful as it allows us to reuse code already written, and if done properly gets rid of any duplicate code. Let's look at some examples. In this case, we're going to look at a vehicle, car, and bike. So let's jump into some code and begin. So I'm going to start by bringing up my shell and my script. So we know that as it regards to inheritance, basically, there are two classes. There's the parent class and then there's the child class. And the child class basically inherits from the parent class all of the properties and methods that parent class have. So right here we're going to create a class known as vehicle, and vehicle is going to be the parent class. So let's begin. So let's begin by creating the class vehicle. Alright. And then we're going to say this class represents a vehicle. Right? Very simple. So what are the properties that we want our vehicle to have? Well, let's begin by initializing it. And what do we want? Well, we want our vehicle to have a name. We want our vehicle to have a model. And our vehicle will also have a year. Alright? And let's initialize these properties. So self.name equal name and self.model equal model. And finally we have self.year equal year. Okay, and that should be it. So these are the properties that our vehicle will have. Our vehicle will have a name, model, and year. And let's give our vehicle some methods or some actions that the vehicle can perform. And a vehicle can be driven. So we're going to create a method called drive. Alright? And all this method is going to do is simply print out to the user, I am being driven. Okay? From. Alright? So we have some attributes and we have a method called drive, which basically prints the user I'm being driven. So if we save and we can go ahead and run this, we can basically create our class. So if we say vehicle and we simply call the vehicle class, so we call the vehicle class and we need a name, which is gonna be, I'm gonna say the vehicle name is a Honda and the model is a Civic and the year is gonna be 2008. Right? Go ahead and enter, and if I call the variable vehicle, you can see I get the object. And similarly, if I try and get the name, I get the name Honda. So you can see that the vehicle class is working properly as it ought to. So let's move on now. So let's create another class which is basically going to inherit from the vehicle class. And this class that's going to inherit from the vehicle class will be known as the child class. And in this case, the vehicle class will be known as the parent class. So I'm going to create a class called car. And essentially, a car is a vehicle. So it makes sense for a car to inherit from a vehicle. And all we're going to do is that we're going to start with the usual class definition. But inside of the brackets, we're going to have vehicle. And what this does, it basically tells Python that this class car will inherit from the class vehicle. So this class car is basically the child class of the vehicle class. And that's how we do it in Python. And I'm simply just going to have a docstring right here that says this class represents a car which is also a vehicle. Alright? And it ends right there. Now I'm going to do, I'm just going to have pass. I'm not going to basically have anything in any definition inside of the car class, just pass. And you'll see how the car class is able to inherit all of the attributes and methods from the vehicle class. And you'll see that as soon as I save and run the script. So I'm going to create a variable called car. And I'm going to create the object from the car, and you see it asks me for a name, model, and year. Well, I'm going to supply the same thing as I did before. I'm going to say Honda. The model is going to be a Accord this time. And the year is going to be 2010. And we'll go ahead and hit enter. And just like that, if I were to call car.name, we get Honda. If I were to say car.model, I get, oops, I have middle. You can see right here I have MIDEL, and it should have been model. So if I say car.MIDEL, you see I get a card. But similarly, and let me change this. This should be model. Incorrect spelling right there. You guys saw that. Well, anyways, let me go ahead and create the car class again. Paste it down here. And similarly, I can do this. I can say car.drive. Call the drive method. If I hit enter, I get I am being driven, vroom, vroom. Even though I did not write any code down in here to basically specify any methods or any attributes. So you can see just by having the car class inherit from the vehicle class, it gains access to all of these attributes and methods. So you can see the whole concept of inheritance is very powerful. Basically allows the child class to inherit any method and attributes that the parent class have without me having to write any extra code. All I did was just write this line right here, which basically tells Python that this car class is going to inherit from the vehicle class, and by inheritance it gains access to all of the parent class's methods and attributes. Alright, so that's pretty powerful, and that's inheritance in a nutshell. But to make this more effective, you're probably wondering, well, a car is a vehicle, and a car would have probably more specific attributes to it that a vehicle wouldn't have, and a car would be able to perform different actions that a vehicle wouldn't be able to do. So basically what we're saying is that this car should be able to have some additional properties and some additional methods along with the properties and methods it already inherited from the vehicle class. And we can have this. So right here now we're going to add a new attribute to the car class, such as make. And the make in this case can simply be whether it is a sedan or a coupe. That means it's either a 4-door or a 2-door car, or maybe it's a 7-seater. That's what make really is. And make is basically a extra attribute that's going to be added to the car class that the vehicle class don't initially have, or don't necessarily have. So let's look at how we're going to basically add additional methods and additional attributes to the car class, even though it inherits from the vehicle class. So let's get into it. I'm going to start by my definition, my initialization I should say, with my init function. You should be fairly familiar with this. If you are not, I suggest you watch my previous video. So what do we need to make a car? Well, a car is a vehicle, so it makes sense that we're going to need the same attributes as a vehicle, such as a name, a model, and a year. And we're going to say this car has some additional properties, and the additional properties that it have, or property that it has, is a make, right? So you can see the name, model, and year are basically attributes that a car must have, because a car is a form of vehicle and all vehicles need to have a name, model, and year. But you can see we have an additional property right here called make. So down here, what we're going to do, we're going to call this super function, right? I'm going to say super dot underscore underscore init underscore underscore. And instead of this, we're going to have name, model, and year. And you're probably wondering, what does this super function does? This super function basically is a reference to the parent class, and it basically tells Python that, hey, a car is also a vehicle, so it's basically going to need a name, model, and year in order to make a car. Because since a car is a vehicle, it makes sense that it has all the properties of a vehicle, which is name, model, and year. And the super function just basically makes reference to the parent class up here. And what we do, we have the init, which is a shortened form for initialization, which tells Python that we need to initialize these attributes, name, model, and year. Okay? And then underneath that, we're just going to have the simple self.make equals make. And this is the additional property that the car will have. Okay? And then now, we're going to say the car can perform some extra actions that a vehicle won't be able to do. So an additional action that a car can do that is specific to the car class is that we're going to have this car class be a Uber. So this car is able to drive as a Uber, basically. So right down here, we're going to have a function Uber, or a method Uber. And all we're going to do is just print out to the user, I am a Uber driver using this car. Okay. We go ahead and we hit save. So here you can see we have an additional method, Uber, which is unique to the car class. And we also have this additional property, which is make, which is unique to the car class. So along with all these attributes and methods that were specified in the vehicle class, the car class also has these added attributes such as make and Uber, which is specific to the car class. So if I hit save and I run, let's create our car again. So this time I'm going to say car is equal to the car class, but now you can see we need a name, model, year, and make. So whereas in vehicle we only need a name, model, and year, in the car class we added an additional property, make, so we need to supply that property when we're creating the car class. So name, I'm going to say Mazda, followed by the model, going to be a RX-8, followed by the year, it's going to be 2015, and the make is a coupe, which is basically a two-door car, and that's it. We hit enter. So if I have to say car dot make, we get coupe. If I say car dot drive, we also have access to the parents method, and we also have car dot Uber. Oops, I spelled it wrong. Car dot Uber. There we go. So you can see we basically have the car class inherit from the vehicle class, and we also added some additional properties and additional methods to the car class that are unique to the car class only. Okay, so down here now I'm going to create one more class. I'm going to create a class called bike, and what I'm going to do, I'm going to say bike is also a vehicle, so it makes sense that it inherits from the vehicle class. Right, and then what we're going to say, we're going to say this class represents a bike which is also a vehicle. Right, and now we're going to start. So what are the properties that a bike will have? A bike will have a name, model, and year. I don't believe a bike will have any additional properties aside from that. So for now, we're just gonna have the bike have one additional method, which is wheelie. So a bike can do a wheelie basically. So we're just gonna have that. What it means to do a wheelie is just driving on one wheel, right? So we're just gonna print to the user, I am driving on one wheel. Okay, and that's it. So let me close this and run this again. So now if I were to call the bike class, I'm going to create a variable called bike. Now I'm going to call the bike class and just apply a name, model, and year, because a bike is a vehicle. So the name of the bike is a Honda. The model is a RR bike, and the year is 2017. Okay. So if I was to say bike.drive, I still have access to all of the various methods. And if I say bike.name, I have access to properties as well. Bike.year, I have 2017. And similarly, I have access to the additional method that is unique to a bike, such as wheelie. So if I call that, I get I'm driving on one wheel. So you can see how inheritance is very powerful. Just by defining the parent class up here and specifying these attributes and methods, by having these child classes down here inherit from the parent class vehicle, you can see we have access to all of the parent classes methods and attributes without having to specify any extra lines of code, or basically write any extra line of code to accomplish that. So you can see how inheritance is very powerful in Python. Alright, so now that you have a basic understanding of inheritance, I want to move on to the next topic. So, what's the next topic? The next topic we're going to talk about is polymorphism. So, what is polymorphism? The word polymorphism means having many forms. In the programming, or in programming, polymorphism means the same function name but different signatures being used for different things, or the same function name being able to accomplish different things. Think of the len function in Python. So the len function in Python is a form of polymorphism, because think about it. When we call the len function on a string, it tells us how many characters are in a string. When we call the len function on a tuple, it tells us how many items are in the tuple. And when we call the len function on dictionary, tells us how many items are in the dictionary, or how many key value pairs are in the dictionary basically. So you can see the len function, even though we use the len function on different objects, the len function still works. So one function is able to accomplish different tasks based on what object it is used on. Because the procedure for counting the amount of characters in a string is different for counting the number of key value pairs within a dictionary, but it's the same function that we use. So you can see, even though it's the same function, it basically accomplishes different tasks, or able to do different things based on which object it is used on. And that is a form of polymorphism. So let's talk about polymorphism as it relates to classes. When we have defined our child class that inherits from a particular parent class, it may be necessary to override or replace some of the parent class attributes and methods with different attributes and methods unique to the child class. So overriding methods and attributes is a form of polymorphism. So let's look at some examples of overriding methods and attributes. Right? So I'm going to bring out back my script and bring out back my shell. So let's take a look at how we can override some methods, since that's the most useful form of polymorphism that we'll look into. Right? You will rarely come across a case where you want to basically override a property, but you can. But for now, we're gonna override some method to show you just how powerful polymorphism is. So to start with that, I'm just going to create a new function under the vehicle class known as fill tank. Alright. And then underneath this, I'm going to say print. I'm going to say my gas tank is now full. Alright. Oh, this is dir. This should be def. Okay. So now the vehicle has a new method called fill tank. And it basically says my gas tank is now full. So if I were to run this, and let's create a bike. So we know that bike inherits from vehicle, so bike should have access to this fill tank method. So I say bike dot fill tank. Hit enter. I get my gas tank is now full. Okay, so it's working properly. So let's come down here now and let's create a new class called electric car. And this electric car also inherits from the vehicle class. Alright. And basically what we're going to say this class, this class represents a electric car that is also a vehicle. Alright. And now, because electric car inherits from vehicle, it has access to all of the same properties and methods. But something you should note about an electric car is that an electric car doesn't have a gas tank. So right here, this method won't be applicable to an electric car. So what we're going to do, we're going to override that method. So how to override that method? We simply call the method name within the child class. So how to override a parent's method in the child class, we simply create a function definition with the same name as the method in the parent class. So in our parent class, we have a method called fill tank. So inside the child class electric car, I'm going to have that same method, fill tank, but here I'm going to specify something else. So in the vehicle class, we have the fill tank print out my gas tank is now full. In this fill tank, I'm going to print out to the user, I have no gas tank. Because it's an electric car. It doesn't have a gas tank. So basically, because we specified a method in the child class with the same name as a method in the parent class, that parent class method is now override. So when we call fill tank on an electric car, this one won't be executed, but instead this one will be executed because this method right here overrides this method up here. Alright, and you can see that in just a minute. So once I save and I hit run, vehicle is not defined. Oops, should be a capital V. Alright, hit save. Now hit run. Okay, so I'm gonna create a E underscore car is equal to electric underscore car. And what do we need to create an electric car? Oops. There shouldn't be a C right here, because that's how I spelled it. And the C should be capital. Alright, there we go. So what do we need for an electric car? We need a name. In this case, we're going to call it Tesla. The model, we're going to call it, I don't know any Tesla model, but let's call it F1. And the year, we're going to say 2018. And we're going to hit enter. So if I say E underscore car, that name, I get Tesla. If I say E underscore car dot fill tank, you're gonna see I get I have no gas tank, because here this method has override the fill tank method, which is found in the parent class. And that is a form of polymorphism. If you think back to the example I gave with the len function, this is how the len function works. When the len function is called by a string object, it does one thing. When the len object is called by a dictionary object, it does another thing. So this is how polymorphism is able to work. We're able to override these various methods and basically have the same methods accomplish different tasks based on which object it is called on. Alright? And that's it on inheritance and polymorphism. So I hope you guys learned a lot. And if we move on, that should be the end of the video. Oh, wait, we still have one more topic to talk about. And we want to talk about multiple inheritance. Alright. So multiple inheritance, as you may have guessed, is when a single child class inherits from multiple parent class. This is entirely possible in Python, but it is a touchy subject. Many programmers believe that multiple inheritance is a bad practice and not necessary, and you shouldn't do it. Nevertheless, I'll show you and I'll teach you about multiple inheritance and leave the decision on whether to use it or not entirely up to you. So, take a look at this example right here. Okay, in this example you can see we have defined three classes, class A, B, and C. We also have another class D which inherits from parent class A, B, and C. So now class D has all the attributes and methods of both class A, class B, and class C. This is known as multiple inheritance. So as you can see, we basically have a class that inherits from multiple parents. Basically, in this example, class D has three parents. It has parent A, B, and C, and it basically inherits all of the methods and attributes from both parent A, B, and C. And that is a form of multiple inheritance. But some programmers are with it, some programmers are against it. I'll leave the decision up to you. Use your own discretion on when to use multiple inheritance. And just a side note I want to touch on is that some of you are probably wondering. For example, this electric car right here, it inherits from vehicle. But I'm guessing some of you are probably saying, would it make more sense for the electric car to inherit from the car rather than inherit from vehicle? And that's entirely possible. So we could do something like this. I'm gonna copy all of this, right? Then what I'm gonna do, I'm gonna comment out all of these right here, and then beneath this I'm gonna paste all of this. Rather than have electric car inherit from vehicle, I can have it inherit from car, right? And just like that I can hit save and run. But one key thing to note, because electric car is now inheriting from car, we will need to supply a make, because in our car class we need a name, model, year, and an extra attribute known as make. So if I were to copy this now, I can copy this and I can paste it down here. So now I need to supply a make, and the make is gonna be a coupe. If I hit enter, I have my e car. So if I say e underscore car and I call Uber, you see I am a Uber driver using this car. So you can see now, because it inherits from car class, it now have access to all of car methods and the car attributes as well. So if I were to say e underscore car dot make, you see I get coupe. So as you can see, this is very powerful. And similarly, because electric car inherits from car and car inherits from vehicle, electric car automatically inherits from vehicle as well. So if I were to say if I were to come down here and say e underscore car dot drive, you can see that I am being driven vroom vroom. So you can think of it as vehicle being the grandparent, car being the parent and electric car being the child class. So electric car inherits from the car class, or not, the car class inherits from the vehicle class. So by virtue of the family tree in programming, it makes sense that the electric car also inherits from the vehicle class as well. So I hope that makes sense. If you want me to reiterate, I'm happy to reiterate, but I hope you got it, that explanation. So let's move on. And that should be it. Alright. Yes, and that's the end of this video. So to recap, we talked about inheritance and polymorphism, and we talked about multiple inheritance. So we know inheritance is basically when we have two classes, a parent class and a child class. And when a child class inherits from a parent class, it's basically inherit all the methods and attributes of the parent class. And polymorphism is basically when the child class overrides a method in the parent class. So by having the same method definition in the child class as the method definition in the parent class, we can override it as we did here. So you can see we use polymorphism right here. So we have fill tank here in the child class, and we also had fill tank here in the parent class. We basically override it, because since we have the same method definition in the child class, it's overrides the method definition in the parent class. And we talked about multiple inheritance and how a class can inherit from more than one parent. And we also talked about a family tree hierarchy where we can have a child class right here, a parent class right here, and then you could consider this as the grandparent class right here. Okay, so that's it for this video. This is the last video in the Python series. So if you've been with me from video 1, then you should have covered all of the fundamentals of Python and should be an adept Python programmer at this point, seeing that you've covered the very basics. So once again, thank you for watching. Please like, share, comment, and subscribe. If you have any comments, if you have any comments or questions, please leave them in the comment section below. And as always, I want you to hit that subscribe button and hit the notification bell so you'll be notified whenever I post new videos. And once again, I want to thank you for watching.